Okay, so before the break, we were talking about area, perimeter, surface area, and volume. And we're just finishing that up today by talking about optimization. So, when we're talking about optimization, we're looking at how we can find the biggest area when we're given the same amount of perimeter. So, looking at this first one, how can you model the areas of rectangles with the same perimeter? You have 12 meters of rope to fence off a rectangular play area at a summer camp. Assume you can only use lengths and widths that are whole numbers. So we know we have a rectangle with a length and width. So the first example it gives us is a width of 1 and a length of 5. So for our perimeter, that's 1 plus 1 is 2, plus 5 is 10, 2 plus 5 is 12. And then to get our area, it's going to be the length times the width, so 1 times 5 gives us 5. So we need to think of other options here. So if we had a width of 2, so that's 2 plus 2 is 4. 12 minus 4 is 8. So between our two lengths, it's going to be 8, meaning each length would be 4. So with this one, we have 2 times 4 for our area, which is 8. So those dimensions do give us a bigger area. We still have another scenario. If we go up to 3, having a width, 3 plus 3 is 6. 12 minus 6 is 6. So that leaves us with a length of 3 as well. And 3 times 3 for our area gives us 9. Okay. If we were to continue on, since our 3's match up, we're then going to be repeating ourselves by going 4, 2, and 5, 1. And we already know the areas of those are smaller than the area of the 3 by 3 rectangle, which actually ends up making a square. So the main idea here is that when we are optimizing or finding the greatest area, then we need to create a square. Okay. What is the relationship between the perimeters of rectangles with the same area? So now we're going to be working in the opposite direction. Before we were given the same perimeter, and now we're looking at the same area. So if we have a rectangle and the area is 36 meters squared, we want to figure out all the possible rectangles that there are that can give us an area of 36 when we're using whole numbers. So the first two examples, we have 1 times 36 gives us 36. The next example, we have 2 times 18. We're going to continue on, finding different amounts that multiply to give us 36. And then after that, we need to find the perimeter for those options. Okay, so if next we had a width of 3, 36 divided by 3 is 12. So that's our next option. And if we had a width of 4, 36 divided by 4 is 9. Okay, we know with the 36, 5 will not work. Moving on to 6, 36 divided by 6 gives us the dimensions of 6 and 6. Okay, so again, once you have found where your dimensions match up, you won't have to continue on because then the dimensions are just flipping. Your width becomes your length becomes your width. So now we can look at the perimeter. So we need to do 2 times the width plus 2 times the length to get us our perimeter. Okay, so we have 3 times 2, and that's 6. And 12 times 2 gives us 24. So the perimeter, 6 plus 24, gives us 30. So we notice with our perimeter, we started with 74, went to 40, went to 30. So our numbers are going down each time. The next one, 2 times 4 is 8, and 2 times 9 is 18. 8 plus 18 is 26. And the last one, 2 times 6 is 12, and 12 again gives us a perimeter of 24. So what dimensions use the least amount of fencing? So it's our 6 by 6 dimension that gives us our least amount of fencing, and the greatest amount of fencing is our 1 by 36. So which shape would you choose for the dog exercise area? You want to minimize the amount of fencing needed. So when we talk about minimizing the amount of fencing, we're actually saving money because we don't have to buy as much fence. So to minimize the amount of fence needed, we are again creating that square shape, and we're going to want the 6 by 6 dimension. So for a given area, the shape that minimizes the perimeter is a square. So a square is going to maximize the area and minimize the perimeter. Okay, so if we look at a different scenario here, we can also look at when we have a rectangle, but it only uses 3 sides instead of 4. So Brandon's customer decides to use an existing hedge as one of the sides of an enclosure. This means that there will need to be fencing on the 3 sides. They still want the area to be as large as possible. So that means we have our width, and then a length. Okay. Do you think he will be able to enclose more, less, or the same amount of area? What shape do you think will have the maximum area? So in the chart, we're given our different rectangle numbers. We are given the first one, it's telling us a width of 1, a length of 30, and a sum of the 3 sides being 32. So the goal is to get to a perimeter of 32. So the fence or the perimeter equals 32 meters. And we're going to be finding what will give us the maximum area. So the second one that there is here, we have a width of 2, a length of 28. So calculating this, it's 2 plus 2 plus 28, and that gets us to the 32. So again, we have 2 widths, but only 1 length. So 2 times 28 gives us 56. Okay, we're going to continue with other options here. And again, every time we're getting the sum of the three sides being 32 meters. Okay, so our next option, we can go with a width of 3. So if we do 3 plus 3, that's 6. 32 minus 6 gives us 26. So our dimensions are 3 and 26. 3 times 26 gives us 78 as an area. Continuing on, we can do a width of 4. 4 plus 4 is 8. 32 minus 8 is 24. 4 times 24 gives us 96. Next one, a width of 5, so 5 plus 5 is 10. 32 minus 10 gives us 22. And 5 times 22 is 110. So we notice our areas are still going up here. So our goal is to get to our highest one, so we're going to keep going until our area does not go up anymore. Next one, width of 6. 6 plus 6 is 12. 32 minus 12 is 20. And 6 times 20 gives us 120. Next one, we can have a width of 7. 7 plus 7 is 14. 32 minus 14 gives us 18. And 7 times 18 for the area will give us 126. Next width can be 8. 8 plus 8 is 16. 32 minus 16 is 16. And 8 times 16 gives us an area of 128. Next option, width of 9. 9 plus 9 is 18. 32 minus 18 gives us 14. 9 times 14 is 126. Okay, so what we've noticed here is that our area has gone back down again. So without continuing any further, we can continue to calculate as we go down here. But our area is going to get less and less every time. So we've actually found our maximum area right here of 128 meters squared. Okay, so the dimensions to maximize or optimize the area, our dimensions are 8 by 16. And the maximum area that we can have is 128. So what we notice, we have a width of 8, a length of 16. So it's actually 2 times our width is equal to our length. Okay, so that's, if we have our hedge on one side, we're going to have 8, 8, and 16. So whenever we have a three-sided shape, the shape that maximizes the area the shape that maximizes the area has dimensions 2 times the width equals the length. Okay, so this is just a summary here. Optimizing the dimensions of a rectangle. If we're using 4 sides, then that means we are creating a square. That's going to maximize the area and minimize the perimeter. Okay, if we're only doing 3 sides, this looks a little different. We end up with a rectangle where the length is equal to double the width. Okay, so just a couple more questions here. What are the dimensions of a rectangle with the perimeter 20 meters to give the maximum area? What is the maximum area? So we know in order to maximize or optimize the area, we need a square. So we need all sides to be the same. And we know that our perimeter is 20 meters. So to have all sides the same, we know that we have to divide this 20 by 4 because there's 4 sides. So that means each side, 20 divided by 4 is 5. So that means the measurements for all the sides are 5. So a length equals 20 divided by 4 is 5 meters. Okay, and then we want to solve for the area. So area equals length times width, and that's 5 times 5, and gives us 25 meters squared. And part B, what are the dimensions of a rectangle with the area 45 meters squared and the minimum perimeter? So again, since we want to minimize the perimeter, we will have a square once again. We know the area of this is 45, and we know that we want all sides to be the same. So that means our length is equal to our width, our area being 45 is equal to length times width, and since our length is equal to our width, we can say that's equal to width times width, or width squared. So to find out the dimensions of the square, we need to solve for the width. To solve for the width, we move the square to the other side and we square root. So square root 45 is our width. And we get 6.7 meters as the length and width of the square. So all the way around, 6.7. And finally, it's asking us to find the perimeter. So our perimeter, we have all 4 sides the same, so we can do 6.7 times 4. And that's giving us 26.8 meters as our perimeter. Okay. So just remember, if you have 4 sides, you're creating a square. If there are 3 sides, you want the length to be double the width. So keep that in mind as you complete your worksheet and let me know if you have any questions.